Processing complex media like video and audio normally demands massive, energy-hungry server farms, dwarfing the phones we use. Relying on those distant data centers means handing over your private information and hoping you have a fast enough connection to get an answer back. We want world-class, multisensory AI directly on our personal devices. The problem is that these highly capable models are usually way too large to fit on a laptop or a phone. The Gemma 4 family resolves this exact tension through a series of specific architectural optimizations. By keeping data processing entirely local, you retain total control over your own inputs. The intelligence sits locally on your machine, completely severing the reliance on cloud providers. This quadrant layout illustrates the 4 distinct modalities Gemma 4 processes natively: text, vision, audio, and video inputs. Google scaled these models down to fit different hardware limits. Even the smallest 2 billion parameter versions can ingest and understand raw audio and video files directly. They are also open source, released under an Apache 2 license, so anyone can download, modify, and deploy them. This specific combination of features puts frontier-level 4sense AI onto everyday consumer edge devices, free of charge. Look at a traditional AI process called embedding. The model tries to load all the contextual data for a single token up front before processing starts. This massive data load immediately overwhelms the limited memory of a standard laptop or smartphone. Traditional models are built for cloud servers that have immense memory reserves. That inefficiency is acceptable there, but it crashes an edge device. Shrinking the AI meant engineers had to rethink how and when the model accesses its memory during calculation. This diagram shows the solution: per-layer embeddings. Notice how the data point receives a tiny sliver of information at each layer, rather than all at once. Compared to the earlier bottleneck, information is injected only when it becomes relevant to that specific calculation step. This creates a massive drop in parameter cost. The model maintains deep context for the prompt without having to memorize everything up front. Per-layer embeddings allow the AI to stay incredibly lightweight while maintaining sharp reasoning capabilities. Traditional AI also forces every single processing layer to calculate and store its own redundant memory states, eating up processing power. This stack demonstrates the shared KV cache approach. The later layers simply bypass their own calculation loops and reuse the memory states already generated by the earlier layers. Combining per-layer embeddings with a shared cache is exactly how Gemma 4 fits long-context multimodal tasks onto standard consumer hardware. In practice, you can hand the model a video of a live concert, and it will correctly identify the instruments and the mood of the performance, entirely offline. As you see in this website interface, it can natively output exact numerical bounding boxes to locate and interact with specific graphical elements on screen. You can also ask it direct questions based entirely on human speech extracted from a video file. However, the smaller models struggle if the audio feed is filled with chaotic, non-speech noise, occasionally hallucinating details. As an autonomous agent, the AI can process live camera feeds to drive a virtual vehicle and easily avoid obstacles. These varied capabilities shift the model from being a passive text generator to an active, interactive agent in the physical world. Gemma 4 relies on 3 distinct pillars: 4 sensory modalities, aggressive hardware optimization, and open-source local execution. Artificial intelligence is no longer locked inside massive server farms. It lives as an independent sensory capability right in your pocket.